another hacking workshop tomorrow and the next day, so that's worth extra credit if you want to come to it. The last one was quite popular, so check that out if you're interested. You do have to come physically. And so we're up to Chapter 5, so let's talk about this, client-side controls. Now, as we talked about this before, the fundamental problem with the web is that HTTP is a stateless protocol. So when you ask for a page, you get the page, and then the server forgets all about it. So it doesn't have any intrinsic way to know who you are or to remember that you have logged in. So you have to add that in with a cookie or something, and therefore it's constantly sending data to the client, and the client has to repeat that data back to the server later. This means that there's a chance for the client to modify that data without the server's permission. And that's a fundamental flaw, and many developers don't understand this, and they just assume that the client will repeat back data without modifying it. You say this is necessary in the web, but it is a vulnerability. And so there's lots of reasons why you might design a system this way, but the fundamental problem is that it's a stateless protocol. All right. So you can have hidden form fields. Now let me get my, I'll get this up in Burp. Let me get my Burp browser going and take a look at some examples. All right, let's get through this and this. And proxy, turn off intercept and open the browser. All right. And now, AD, one of my websites. Let's see, is it hidden.html? It's hidden.htm, okay? Right, and I got to tell it that it's HTTP. It assumes it's HTTPS, but this site is old-fashioned, and it's actually HTTP. All right, so here you are. So, for example, here you got an iPhone. The price is $449. So if you buy one, it tells you you completed one phone for $449. All right, now if you look at that in Burp, go to the history, you'll see here was a post that went up to the server to buy that phone, and the post passed the quantity and the price from the browser up to the phone. This keeps on happening. Now, this would suggest that the price is actually controlled by the browser. So if you send this to the repeater, you can try changing the price. I can just change it to say 4 and send it. And now, if I should be able to render this, yeah, see the page more or less there. Now I bought a phone for 4. So that's the point. It really is believing the price that came from the client. There's a common flaw. You put data on the client and you assume what the developer is doing, which is easy to understand. They're assuming that I can't change the price, because if you look at the source code, let's maybe inspect would be the easiest way to do it. Inspect, yeah. All right, if you look at that line, that's the price, and I guess it's just static. Right, in this case it's just static here, but I thought it was actually a hidden. Here's the form, that's what I wanted to see. Yes, there is a price, but it's hidden. There's a form field containing the price, but it's got a fixed value and it's hidden, so I can't see it here to change it. But what the developer failed to understand is I can use a tool like Burp and change it. Even though I don't get the option of changing the field, I can change it by manipulating the network traffic outside the browser. All right, so, all right, and by the way, if the response comes back zipped, you can remove the accept encoding line to make it come back in plain text readable stuff. But anyway, all right. And you can use match and replace to change things here. You could turn off the accept encoding all the time to make, there's a whole bunch of ways you can adjust responses in Burp. But anyway, let's take a look at the cookie discount. Got a couple more demos of these things. So down here, this is going to have you're going to set a field to get a discount. And now I can buy a phone with a discount of 10. So I'm getting it with a discount of 10. But once again, of course, we're going to see that traffic was under the control of the user. So here's the get to set the cookie. So when you do tend to get the cookie, the response sets a cookie setting discount equals 10. So now when you post this, it's going to include that cookie. Here's the quantity, here's the price, and up here someplace is going to be, here's the cookie, discount equals 10. But once again, that's stored in the browser. And it's being trusted from the browser. So I can send this to the repeater. And if I send it now and render it, I get a phone with a discount of 10, but I can just change that discount to 100. And now I'll get a discount of 100 because once again, the developer believed data that came from the client. All right. And all right, let's go back to here. Okay, so we've done that. All right. So you can have hidden URL parameters. That's another way. Now, sometimes URL parameters are right up here. There's various ways to conceal URL parameters, but all these are unsafe. There's ways to make it more or less obvious that what's going on. You can use the post method, you can put it up here, but if the data is ultimately coming from the client and there is no way to stop the user from changing the data. Another thing people often do is put JavaScript in the browser. If the field is too large or the field is too small, pop up a JavaScript error, but you can turn off JavaScript in your browser, and even you can just put in a valid value and let it go to burp, and burp, of course, is not running the JavaScript anymore. So, all right. You can look at the referrer header. This is another problem. The referrer header in a request is just like the sending phone number you see in telephone systems. It is not verified at any level. So there's a common, this is how swatting works. You can make a malicious voice over IP system that makes a phone call and changes the caller ID to anything you want, so you can change it to somebody else and make them think that they're getting called from somebody and then say, I've got a gun, I've got a hostage, and they'll run to that house. The police use the caller ID and use that location to find out where you are. And it's not verified in any way. Neither is the from email address. This is why spammers will send email and they'll put a false from address on it so you can't send any replies back to them. And in the same spirit, the referrer is arbitrary and can't be trusted. So if I go here to the referrer, you can only buy an iPhone from Apple. So if I submit, it's going to say fail. You can't get in because you need to come from Apple. But you can just modify the referrer. So here, you'll see the referrer is in the request somewhere. There it is. There's the referrer. It's coming from Sam's class, which is no good. So you have to send it to the repeater, and you have to change that to Apple. And now it'll assume you came from Apple and let you have it. And this, that people often, which again, the developer makes an understandable mistake. They assume that this really tells you where they came from, but it doesn't. It can be modified. It can lie about where they came from. And we'll see as we go forward, there's a lot of attacks where you skip the stages of something. Like you choose the product, you fill in your address, you fill in the payment, and then you ship the product. But you can maybe just skip over the payment part and go right to shipping. And they might trust something like the referrer to make you think you did the pages in order, but there's no reason to believe you actually have. All right. And so you can conceal the data. You can have values that are obfuscated. I think I better shut that door. They're always noisy out there. Oh, it is shut. Well, can't do anything more about that then. Anyway, all right. So if your data might be encrypted, now that's a common solution. If your data is actually encrypted, then maybe you won't be able to modify it because you won't know. So you have a pricing token here. That would be nice. The problem is often the encryption is not good enough. Like I just mentioned in the news part, the supposedly random key for WPA made by this WPS system is apparently not random enough, so it's easy enough to crack. So you might be able to find the system. Sometimes they do something like use the MAC address or something. You might find a function somewhere else where you can use the encryption routine. There was cases where your username was run through the same encryption, so you could use that to guess what was hidden, and you encrypt it there. You'd also run it through you choose a username, which would you could create an encrypted field that would pass the test with different data in it. by crediting it to your username, that sort of thing. If you can, you might be able to find a way to use the encryption functions. This is what I've often done with malware. I don't figure out their encryption routine, I just find it, and then I use their code to encrypt and decrypt stuff. All right, and you can also try to break it with overlong values, different character sets, null bytes and such to break the logic on the server side, and we'll do that in the projects. Now, Microsoft's scripting language, ASP.NET, provided a solution for this called viewState. This field is created by all ASP.NET fields, so you can use viewState add to add data fields to the viewState, and then you pass it all as one blob of data. So the form sent to the user will now look like this: viewState and just this long base64 blob of junk, which contains a bunch of values. In the early version, it was just base64 encoded. It was not encrypted. But in later versions, it actually has a cryptographic signature, a MAC on it. So that's a keyed hash at the end. And if that is done properly, then it will recognize if anybody tries to alter it and reject it, which is nice. However, there was an attack that came out in the news just a week ago where a major website got hacked because they were using viewState, but they just copied the example code, including the example key, and just used it that way. And this is something that happens very, very often. People run encryption code without providing their own random key. They just use a well-known sample key. So that means everybody has the key and you haven't accomplished anything. All right. And then you can try length limits. Here's the source code for this one. You can put max length equals 1 in a form field. And if you do, you can't type in more than one digit. So if I go down here, I can buy one iPhone. But if I try to buy 10, it won't take the second digit. I can only type one digit into this field. So again, the developer might imagine that will stop people from doing it, but it won't stop them if they have burp. They can just go here, run it, send it to the repeater. And down here's quantity equals 1. I can put the 0 there, and now I'll get 10 phones. So once again, they're all very simple, all very closely related. These are all flaws caused by trusting what happens on the client side. All right. If you refresh a page, then a page is not modified, and that's something you get. Your browser will not send it again because the server won't send it again because your browser has already cached it. That's a 304 error. But you can send a request like if modified since and if none match. These are headers you can use to control caching on the client side and when it should refresh a page. If you want to force a full reload, use shift refresh or use burp to remove these headers. So it will always just freshly reload the whole page. All right, and then I mentioned before, script-based validation. You can put a JavaScript on your page like this that will look at a value and then say quantity is too large if it's greater than 5, and people do this all the time. And it's not a bad thing to do. The point of it is, if people are filling out a form, you say the zip code must have 5 digits, the email must have an @ sign in it, and things like that. You don't bother sending in the data to your server until it passes those rules. This will avoid wasting everybody's time, but you can't trust that any of that has actually happened. You put it on the end to give the user a better experience. You put it in the client, but at the server, you have to revalidate all the fields because you do not know that any of these rules were actually obeyed. And so you can defeat it here. Here's script-based validation. If I put in 6, then it pops up a box saying quantity too large. It never sent anything to the server at all. It ran JavaScript locally. But what I can do, of course, is put in 2 and submit it, and then go to burp and pick it up here and send it to the repeater. And there's the quantity at the end, and I can make it 20 from here. And now I will get to buy 20 because the JavaScript doesn't run in burp. I could also modify the script in my browser or turn off JavaScript in the browser. Any of those would work. All right. So if you use JavaScript for input validation, then you test it by submitting data that would have failed validation using your proxy, determine whether validation is also performed on the server. And you have to test every field. All you need to do is find one field that is not being tested, and this is usually what happens. People usually have a site and they remember these things, but somewhere they forget. So there was something that was added later by another developer or something that was carried in from a previous version or a previous project. It's usually some little thing in the corner that they neglect. All right, anyway. All right, like I say, client use side validation can improve the user experience, but you have to remember that you can't trust it and you have to repeat it on the server. All right, and then there's disabled fields. Let's take a look at that one. If you go to 7 here, here's a disabled field. I can put in a quantity, and the price is there, but I can't change it. So when I submit, I get a phone for $4.49. And so again, of course, one simple trick is the same one we've been doing. Even though the field was disabled, the quantities one is here. Well, in this case, let me read my notes. That one didn't seem to send it up to the server either, although I should have. Type text price, should have sent the price up to the server. Let's see. Disabled elements can't be changed and are not sent to the server. Okay, so it's not trusting it from the client. But you can insert it. That's right. This is a cute one. You notice there's something named price, and it was not sent to the server. But you can add it, even though the developer didn't put it there. I can put it here, and price, and it got to go to the repeater. Let's send this one to the repeater. All right. Even though I didn't send the price, it's possible that the script on the server side will listen to it if I do send it. So if I put ampersand price equals 7 and send it, now I do get a phone for 7. This happens pretty often in a lot of the examples in your book. You add a field that was not supposed to be sent, and the server trusts it. But there was a case that'll come up later where they, in fact, looked for the administrator page, didn't have a certain field, and therefore they took a request lacking that field as proof you were the administrator. So it's the kind of thing that can happen. Remember, the server script doesn't necessarily have to see every field. It will process it according to whatever logic they write on the server side. And here they might say, if it comes in without the price, use the price from the server side. If it comes in with the price, then believe the price that came from the client. That's easier to do than you might think. And of course, you can defeat all these another way. You can modify the source code of the web page in Burp. What you do is go into response modification and unhide, and let me show you this. It's in settings. You go proxy, settings, and down here is response modification. So I can unhide hidden form fields, prominent, enable disabled form fields, remove length limits, remove JavaScript form validation. You can do all that. And now, if you just reload the original page here, it'll change it. So the hidden field just appears here, so you can change it and get a phone for 4. This one here, the hidden field price, again, just appears and you can change it. This time, the length limit is no longer there. You can just type in as much as you want. It automatically removed it from the source code for you. And here, the script-based validation just won't run anymore. I can put in 23, and it doesn't care. So this is an easy way to do it. And here's the disabled field. Well, it's not disabled anymore. So you could do that yourself by just going into the HTML and modifying it. But Burp is a convenience feature. Burp will do it for you, and that makes it trivial to defeat all these client-side defenses. All right. Let's see a question. How is it possible to tamper with the payload if you have HTTPS? The HTTPS is a very good question. HTTPS does not prevent any of this because I'm not messing with the encryption. I'm changing the HTML, and the request that goes out is all HTTPS does is encrypt it in transit. So I take the request that was going to have a price of 400 and I change it to a price of 4, then it gets sent off encrypted and decrypted. You know, all the HTTPS is like a cable between you and the server, which means nobody can mess with it between you and the server. But I'm changing it before it enters the encryption, and it gets decrypted at the other end. Almost all the attacks we're going to do go right through HTTPS because we're sending data to the server, which is misunderstood at the server end. All HTTPS is about is data in transit, and we're not changing it in transit. We're changing it before it goes. You have to intercept the HTML. Yeah, you intercept the request, the HTTP request, yes. Now, if I was not running Burp on my machine, but I intercepted it after it entered the router, like somewhere on the internet, then I would have the problem doing this because I would now be getting encrypted data, which I don't have the key for. But here, I'm intercepting it before it leaves my machine. It's a very good question. And by the way, if this was an HTTPS field website, I would be getting warnings from my browser saying there is a man-in-the-middle attack in progress, and you shouldn't trust it. The HTTPS is not working correctly. But most users will just click through that warning. But your browser will warn you that someone is intercepting your HTTPS connection, and Burp will automatically generate a fake HTTPS certificate which won't pass validation. That's how it does it. So technically, you do get a warning, but in practice, very few people pay attention to that warning. So let's take a look at a Kahoot. This is 5A. All right. Yeah. Anyway, I'm glad someone asked that question. It's a very good question. Yeah, Mitnick. He died recently. Very famous hacker. Nice guy. But he did have to spend some time in prison. All right, I guess we got everybody. All right, so why do web apps send data to the user and expect the user to repeat it? He didn't answer that. This is a way to simplify coordination across multiple servers. Rather than finding some way to maintain the state on the server and communicate it to all the other servers, bouncing it off the client is often the most convenient way to design the website. All right, which one is easy for the end user to modify without using Burp? URL parameters are right there in the URL bar. You can just type them in. You don't need Burp for that. But these other things, you pretty much need Burp for them. You can fix some of them in developer tools in the browser, but Burp is a better tool for it. All right, how do you make a compressed response readable? The accept encoding, most browsers accept zipped encoding, which means that the server can zip it and send it to you, and that's usually good because the network traffic connection is usually slow, and the processing time required to zip something is not much. So it sends you zip data in your browser, unzips it, but if you get rid of accept encoding, then it will send it to you in plain readable HTML. All right, how do you completely reload a page? Yep, that's shift refresh. All right. Good. All right. So then there are browser extensions. And like I say, these aren't that common anymore. It used to be Flash and Java added to a browser. And they're also, in principle, subject to user modification, but it's less obvious. So, for example, if you have a casino app, you can tamper with the game to bring advantages, find a hidden parameter, receive information about other players, and in fact, a lot of online gambling sites are rigged. There's no way for you to verify they aren't, and if you think about it, it's an easy way for the casino owner to make more money. So these common browser extensions all have the features of compiling things down to bytecode that run in a virtual machine, and they may use serialization to combine data together in a blob. Java deserialization has led to a lot of security problems. So Java applets run in the Java virtual machine. This is used in enterprise software. It's not used that much for ordinary clients anymore. It used to be common to add a Java extension to your browser. It's not that popular anymore, but it's very important in the Android world. If you're taking the Android app hacking class, the Android apps are written in Java and compiled to bytecode, and we're going to be totally working with that a lot, taking them apart and modifying them. So serialization is these Java serialized objects. And there is a plugin in Burp to understand this. So if you look here, you have a Java serial object. It's just a long blob of junk down here. And if you deserialize it, it then shows you the data. So this is the original product, Microsoft's view state in ASP.NET is an imitation of it. It's a way to take a bunch of data and turn it into one blob. And, all right, and there's a plug-in to take it apart. All right. So here's some tips. Make sure you're getting all the traffic. Checking with a sniffer like Wireshark is good to make sure that your traffic is reaching the right spot. Unpack your serialization with an unpacker, and look at responses that trigger client-side logic. Look for things like user equals admin, things like that. Admin equals true, admin equals false. Try to correlate things, critical actions and communication with the server. One thing that's good fun is to just run a tool like Wireshark and see when data is sent to the server. When Windows 8, I think, came out, or maybe Windows 10, everybody freaked out because if you did this and you browsed the web, you could see that it was sending the URL of every website you went to Microsoft. And people got really mad saying Microsoft is spying on us. And you could say that. Now, what Microsoft said is we're trying to block malicious URLs with a cloud service. And instead of running everything locally on your machine, we run a lot of our defenses in the cloud, so we send information to the cloud to protect you, which is also what endpoint detection and response tools do. But in both cases, that is a concern. That compromises your privacy, and it does expose your company data to some third party, so it is a thing to be aware of. So watching what network traffic comes from actions can be quite enlightening. And so if a Bank of America Android app, for example, you can pull it from the phone with ADB, and then you can take it apart with APK tool. APK tool will unpack it and reveal the code. And so when you do, you can see here's the code, and it has a bunch of files, and they've used a free product from Google called ProGuard, which is completely worthless, to try to obscure their code. It changes some of the names of it to BR, BS, and BT, but it doesn't change all the names. And important things like here, like credit card details activity, still have a readable name. So it doesn't, in fact, prevent me from finding things. And so you can just go in here and find the code that performs a login. It takes the username and password and it puts it in some local variables called P3 and P4, so you can easily add Trojan code to it, which will put the card number or the username and password in the log, which is an unsafe place to put it. And if you were willing to write a more complicated script here, it could be sending it off to a third-party server. You can then rebuild the app, sign it again, and run the modified app on your phone and steal data from it. and this is true, almost every Android app is vulnerable to this. You can make a counterfeit app that looks exactly like the real thing and works exactly like the real thing with additional modified Trojan activity in there. This can be prevented, but almost nobody bothers to prevent it. Anyway, like I say, here's what ProGuard does. Here's the original with all these PayPal and Phone Valley and all this jazz. If you obfuscate with ProGuard, it changes a lot of these names to just A, B, and C, but it doesn't change them all. I think the functions that have parameters still get their old names, and the parameters still get their old names. So in fact, it doesn't really protect your app very well at all. There are third-party tools like -O that will really obfuscate it. It will change every variable name to like 10 random characters. And that will slow you down as an attacker, although it doesn't stop you. What I did was I wrote Python code that would just log every single parameter. And then I run the app. It runs really slowly. I log in with a password, and then I look in the log to find out where my password is, and I can find out which variable has the password, even when they obfuscate everything. But it does make you work more. Anyway, so handle your client-side data carefully. Don't send critical data like prices from the client. Instead, just send a product ID from the client and look up the price on the server. If you have to send important data, then use something like the ASP.NET view state with a signature, sign or encrypt it so the user can't modify it. And all client-side validation methods are vulnerable because, as you see, we can use a tool like burp, so we're totally outside the browser, so none of your methods are running, and I can modify the data outside the browser. So anyway, your intrusion detection system should be aware of this, and if people get data which violates your client-side rules, you should realize that proves this person is an attacker, and you should not terminate their session, block their IP address, things like that. You shouldn't let a bad guy try hundreds of different attacks. After you get something that's obviously not coming from your form, that's sufficient evidence that this person is not a legitimate customer, they're an attacker. Almost nobody does this, but they should block you at that point. Anyway, let's take a look at another Kahoot. All right. The one thing a lot of people do is if you just try logging in with a whole bunch of passwords, a lot of sites will block you after like 10 wrong guesses or something. They do at least do that. But they could go a lot further in noticing obviously suspicious data coming in. And as we move towards a zero trust model that the government wants us to move towards, we may get there. Logically, we should have like an AI deciding whether this looks suspicious. Maybe we'll have that one of these days. Various people are trying to develop it. Kanye. Haven't heard about him in a while. Man, what a way to destroy your career. Elon Musk is not far behind him. You know, just coming out as an open Nazi is a bad career move, I would think, although Elon Musk seems to be surviving it. But Kanye did not survive it. Lost his whole empire. All right. All right, so which technology is not compiled to bytecode? Right. Yeah, HTML is just processed by your browser. It's not compiled at all, and it's not a programming language. It doesn't contain commands. It just contains formatting. Anyway, JavaScript is the programming language you find in HTML, and it is also not compiled to bytecode. It's just run inside the browser. And by the way, about 10 years ago, Firefox discovered that JavaScript in Internet Explorer was running incredibly slowly, and they improved their function to run it about 50 times faster, and that led to the modern JavaScript-based frameworks. Microsoft had written such an inefficient engine for their web browser that people thought you couldn't use JavaScript to do much, and they just improved it, and therefore for a period of time when you could only load advanced websites in Firefox and you couldn't load them in Internet Explorer, Microsoft caught up after that. Anyway, all right, so what should you do with received data that violates client-side validation rules? Yeah, all these things happen. The demonstration today, we just use it as it is and get fooled. A lot of people will just clean it up and use it, or they'll make the user re-enter it. Probably the best thing to do is to terminate the session, log that this is the IP address of an attacker, that sort of thing. All right. How can you make data from the client trustworthy? You sign it with a cryptographic signature, and then the user cannot modify it without invalidating the signature. As long as you validate the signature on the server, and as long as your encryption routine is a good one, this is perfectly fine. All right. And of course, somebody using a fake name like Kanye is not going to get their points unless they tell me who they really are. Anyway, all right, so let's stop this recording.